Hi everyone, this is Nicole Utek on Extending Children's Mathematics, Chapters 7 through 9. Chapter 7 talks about students' understanding of decimals. It explains that decimal instruction leads students to combine their understanding of base 10 with their understanding of fractions. This understanding of base 10 numbers and fractions as relational can help students to learn decimals. This understanding also allows students to apply their comprehension of whole number calculation to produce methods for decimal computation without direct instruction. Issues arise with students studying decimals when they do not have a strong understanding or foundation of fractions or base 10. One of the issues is that students lack the experience needed to develop a strong relational understanding of base 10 and fractions by the time they study decimals. One of the causes of this lack of experience is because students are introduced to fractions, place value for numbers over 10,000, and decimals all in the 4th grade. Another issue arising with students studying decimals occurs when problematic instruction happens with base 10 and fractions. Issues in instruction with base 10 include when instructors focus on naming places and writing numerals but do not pay enough attention to understanding groups of powers of 10 and the relationship among these groups. Issues in instruction when it comes to fractions are when instructors focus on counting parts of the whole but not enough attention is paid to developing a relational understanding of fractions as amounts and relationships among fractional amounts. To help students succeed when it comes to decimals, it is suggested that instructors should support children early to build an understanding of base 10 and fraction concepts. This allows students to be more likely to develop a relational understanding of these concepts, which can serve as a basis for learning decimals. However, teachers may not always have this option and have to teach decimals to students who do not have a strong understanding of base 10 or fractions. But teachers should still help these students to build a strong foundation of base 10, fractions, and decimals, although these students may not proceed as far as instructors would like. Chapter 8 of the book talks about students' understanding of operations on fractions and decimals. It explains students' strategies for adding, subtracting, multiplying, and dividing fractions and decimals. It suggests that instructors help students to solve and discuss multiple groups problems and partial groups problems, as these problems give students further opportunities to develop relational thinking. Relational thinking becomes important here because it contributes to the understanding of operations on fractions and decimals. It also prepares students to start solving algebraic equations with insight. Furthermore, long-term relational thinking about operations supports student development of math proficiency more effectively than just the knowledge of standard algorithms alone. Chapter 9 of the book talks about learning to use children's thinking to guide instruction. It really advises instructors to listen to students. One way to do this is to promote discussion among students on strategies used and what was learned by the students. These discussions can reveal the ways in which students think, which can help the instructor find ways to promote this thinking. Also, instructors are advised to use what is heard in these discussions to design problems that encourage students to draw on their own conceptual understanding. Finally, these discussions where instructors listen to students give students the idea that the instructors value their ideas, which builds their confidence and gets them participating more and relying on themselves for their learning. I think chapters 7 through 9 can relate to many of the readings discussed throughout the semester. One reading in particular, Connecting Arithmetic to Algebra, really spoke to me in regards to this, chapters 7 through 9. I felt that the instructor and the classroom talked about in the article really exemplified listening to the students and getting students discussing the strategies used and what they have learned. I also felt like this instructor made a classroom environment where students felt like they were being listened to and were more open about participating in the discussion. In regards to my own teaching philosophy, I find that chapters 7 through 9 really covers the idea that students need to have a strong foundation of things where teachers can build on that foundation and build on what students know. I think that without this strong foundation of certain concepts, it's hard to get students to keep continuing and advancing in that particular subject. Finally, I completely agree with the book when it comes to having instructors listen to students. I think it builds mutual respect between the instructors and students, and it really gets a classroom environment going that has a lot of discussion and students participating with one another and building ideas off of each other. And in regards to the whole book, I'd have to say that I really enjoyed the book. I liked how it was laid out, how it talked about in order how students build concepts of mathematics. I also really liked how it visually and verbally gave examples of problems so that the readers, we can use them in our own teaching practices. I also really enjoyed how the book promoted individual student thinking and allowing students to use their own logic to reason through problems, as I think it is a really beneficial strategy in school. I think it helps students understand why things work, and I think it helps them to apply this information outside of the classroom. And finally, the book introduced me to relational thinking, which is now a strong concept in my mind. I find it to be very important for students when it comes to math, and I plan on using relational thinking strategies and developing them in my students when I gain my own classroom. Thank you all for listening.